Ever wondered how your voice travels over a phone call, or how your favorite TV show reaches your screen? The magic behind these phenomena is the result of transmission technology. This technology serves as the backbone of our global communication networks, allowing us to share and receive information across vast distances. The world of telecommunications recognizes two primary forms of transmission: analog and digital. Analog transmission, the older of the two, uses continuous signals to convey information. It's like a painter using a brush to create a continuous stroke of color. On the other hand, digital transmission uses discrete signals, much like a mosaic made up of individual tiles. Each type has its own advantages and specific use cases. Understanding the differences between these transmission methods is key to navigating the complex landscape of modern communication technology. In the next few minutes, we'll delve into the world of analog and digital transmission. Let's start with the older method, analog transmission. This is a method where data is transmitted by continuously varying the amplitude, frequency, or phase of a carrier wave. Just think of it like the flowing waves of the ocean, constantly fluctuating and changing. This type of transmission is particularly suitable for transmitting audio and video signals, making it a common choice for radio and television broadcasting, as well as first-generation telephones. Analog transmission has some unique characteristics. Firstly, it transmits signals in a continuous waveform, using variations in voltage, amplitude, frequency, or phase to represent information. It's like a painter using different brushstrokes and colors to create a picture. Secondly, analog transmission has a natural compatibility with analog signals, like the human voice. This makes it a fitting choice for environments where digital technology isn't necessary or feasible. Furthermore, it can achieve high levels of performance in certain conditions, such as low noise environments. However, it's not all smooth sailing for analog transmission. It has a few disadvantages that are worth noting. For one, it is susceptible to noise and interference, which can degrade the quality of the signal. Imagine trying to paint that picture we mentioned earlier, but someone keeps jostling your arm, causing your brushstrokes to go astray. Additionally, analog transmission isn't the most efficient when it comes to bandwidth usage. It's like trying to fit all your groceries into a small bag. You might be able to do it, but it's not the most efficient way to go about it. Finally, analog devices generally lack the capability for error checking and correction, which are inherent in digital systems. This means that if something goes wrong in the transmission, there's not much that can be done to correct it. So, while analog transmission has its benefits, it also has some drawbacks, especially when compared to digital transmission. Now let's turn to the newer method, digital transmission. This technique involves encoding data into distinct signals, typically represented as bits, before transmitting them. You can think of it as a language of zeros and ones, a binary code, where each 0 or 1 is a bit of information. Digital transmission requires the conversion of analog signals to digital before transmission. This process, known as sampling, essentially breaks down a continuous analog signal into a series of discrete digital values. It's like taking snapshots of a flowing river to capture its essence in a series of still images. Today, digital transmission is the backbone of modern telecommunications. It's used in our cellular phones, our computers, our tablets, and even our smartwatches. It is the language of our interconnected world. But what makes digital transmission popular? Well, it has some significant advantages. For starters, it has a higher noise immunity, making it more reliable in noisy environments. Think of being able to have a clear conversation in a busy cafe. That's digital transmission for you. Next, it's easier to apply encryption and data compression in digital transmission. This means your data can be securely sent and received, while also saving on bandwidth. Speaking of bandwidth, digital transmission is more efficient in its use, allowing for higher data rates. Finally, digital transmission facilitates error detection and correction mechanisms, enhancing data integrity. It's like having a built-in proofreader, ensuring your message is received exactly as you intended. However, as with anything, digital transmission does have its disadvantages. It requires more sophisticated technology and infrastructure. Also, analog signals must be converted to digital, requiring additional hardware, such as analog-to-digital converters. Moreover, there's a potential for quantization errors during the analog-to-digital conversion process, which could impact the quality of the transmitted data. As you can see, digital transmission has several advantages over analog transmission, but it also has its own set of challenges. Regardless, it's an essential part of our digital age, powering our gadgets and connecting us to the world. We've discussed both analog and digital transmission, but what's the real difference between the two? Let's dive into the key differences. Starting with the signal type, analog transmission uses continuous signals that vary smoothly over time. Imagine a sound wave that ebbs and flows. That's an analog signal. On the other hand, digital transmission uses discrete binary values, that's zeros and ones, to represent information. It's like a series of on and off switches, which can be interpreted by digital devices. Next, let's talk about noise and error handling. In an analog system, the signal is susceptible to noise and interference, which can degrade the signal quality. With digital, there's a higher resistance to noise and errors. This is because digital signals can be regenerated and cleaned up at each point in the transmission path, making them more reliable, especially in noisy environments. Now, on to bandwidth usage. Bandwidth is like a highway for data, and efficiency is key. Analog transmission can be less efficient in its use of bandwidth. Digital transmission, however, can more efficiently use bandwidth and support higher data rates. This is because digital signals can be compressed and multiplexed more easily, allowing more information to be transmitted in the same bandwidth. Regarding the technology required, analog systems can be simpler and cheaper to implement in environments where digital technology is not necessary or feasible. Digital systems, however, require more advanced technology for encoding, transmitting, and decoding data. This includes the need for analog to digital converters to transform signals before transmission, and digital to analog converters for the receiving end. So as you can see, analog and digital transmission are fundamentally different in their signal type, noise and error handling, bandwidth usage, and the technology required. These fundamental differences make each method more suitable for certain applications than the other. But remember, it's not about which one is better overall. It's about which one is best suited to the specific needs of the task at hand. Now that we know the differences, where are these methods used in our daily lives? Let's start with analog transmission. It's like the old friend we grew up with, always there in the background. Remember the first generation telephones or those classic radios we used to fiddle with to catch our favorite station? Those were prime examples of analog transmission. The technology is also used in television broadcasting, where the continuous signals carry our favorite shows right into our living rooms. Analog transmission is often the go-to choice where a direct and continuous representation of sounds is needed. This makes it perfect for FM radio broadcasting. It's also used in traditional telephone networks, where the natural compatibility with human voice proves advantageous. But as technology advanced, we've seen a shift towards digital transmission. The digital revolution has touched every aspect of our lives, from the way we communicate to the way we consume content. Your mobile network, that's digital transmission at work. The call quality and data speeds we enjoy today are largely due to the efficiency of digital transmission. It's also the backbone of modern computing, enabling fast and reliable data transfer between devices. Digital transmission is also the reason why we can stream movies and music online. Platforms like Netflix and Spotify rely on this technology to deliver high-quality content to millions of users worldwide. It's also prevalent in digital TV and satellite communications, where it provides clear and interference-free broadcasts. Internet protocols, the rules that govern data transfer over the internet, also use digital transmission. This allows for seamless communication and data exchange, making our online experiences smoother and more enjoyable. So, whether you're tuning into a radio station or streaming a movie online, you're experiencing the wonders of analog and digital transmission. The choice between the two isn't about which is better overall, but rather which is best suited for a particular application. It's about understanding the strengths and weaknesses of each, and applying them where they shine the brightest. In the world of telecommunications, understanding the difference between analog and digital transmission is key. The continuous waveforms of analog transmission, with its natural compatibility with signals like the human voice, finds its niche in areas like radio and television broadcasting. But it's susceptible to noise and interference and is less efficient in its use of bandwidth. On the flip side, digital transmission, with its distinct zeros and ones, shines in the realm of modern telecommunications and computing. It boasts higher noise immunity, efficient bandwidth usage, and the ability to apply encryption and data compression. However, it requires more sophisticated technology, and the conversion of analog signals can introduce potential errors. Whether it's the traditional use of analog in FM radio or the digital dominance in our mobile networks and internet protocols, each has its unique place. Whether it's analog or digital, each transmission method has its place in our technologically advanced world. Understanding these methods gives us a better appreciation of the technology we use every day.